draw it together. I keep making bell curves. Is that okay? Why is it okay? Well, what guarantees there's a bell curve there? Rhymes with ventral squimmet. There it is. I don't know what rhymes with central. Ventral. Ventral, the fin on a fish. There we go, you got it. Central limit there. It guarantees when you start sampling, the sampling distribution has a bell curve. We get that. And it's centered on the average. So, here, average lung function parameters. So we're assuming average lung function for folks, healthy, non-smokers, I'm assuming non-smokers. But the control group, right, the baseline lung function parameters are averaging here. They're not all there, there's a plus or minus around there, right? There's a plus or minus around that, it looks like this. Okay, who are these people over here? Who are people over here? I'm kidding. I just swam 3,000 meters yesterday for a friend, and the dude next to me lapped me a few times doing that. I'm envisioning Hardys here. People with crazy, crazy lung capacity, right? Very lung function parameters, meaning that the bigger that number is, the more efficient your lungs are. I'm sorry, better function. I should have said better. Better lung function, worse lung function. So we're talking about people with super, super awesome lung function here, right? If we put people in a room with secondhand smoke, and they moved from here to here, what would that do to the anti-smoking campaign worldwide? Right, all of a sudden it's like, oh my God, smoking makes your lungs healthier. Of course that doesn't happen, right? That doesn't happen. Because what are these people down here? What's happening to their lungs? It's decreasing. Now how about here? Do we call mom and say, Mom, 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 Mom? How about now? How about now? Okay, we're starting to believe it more, right? At what point do we call mom? Down here? Got no problem with that. Let's color code it. I got red, I need red. There we go. What's that area we agreed on today? 5%. That's a good agreement. When we get far enough down to tag into this surprise region, that's where we call mom. And we say, Mom, guess what? I think secondhand smoke actually ruins your lungs. Okay, it's old news now. But even 100 years ago, this wasn't. I mean, smoking was very fashionable 100 years ago. So, fair so far? So, where did my asterisk land for lung function parameters were significantly reduced from 0 to 1 hour? Where should I put my asterisk? Here? Right below. Oh, good, Brandon. Somewhere in here, yes? So there, this would be the data gotten after the 1 hour of secondhand smoke exposure. That's where we landed. Now, Brandon said right to the left, or right over, or right, however you said it's perfect. Right below it. Come on, can I put it here? Can I put it here? Yeah, I can put anywhere down there. The key is it in there or is it in here? That's what I'm interested in right now. And it's definitely in there. That's why it's less than 5%. We were expecting, this might sound stupid, but we were expecting secondhand smoke to have no effect whatsoever on lung function. And surprise, surprise, it made it worse. Surprise, surprise. Fair enough? Fair enough, maybe. Believable? Okay. But then what happened? After we pulled them out of that smoke-filled room, let them sit outside, as all I have to do after I got done playing hands-on throat track, wander back outside, take a couple huge diaphragm-cleansing breaths. Of course, then Andy's blowing right back in my face from outside, regardless. But what happened to lung function parameter after time? That's the second p-value. Whoops. That's the second p-value. It then increased back. Notice how it says, but at 3 hours they were at baseline levels. At baseline levels. Let's go with green. What does at baseline mean? Did they land right back here? Maybe, but more likely what, Elizabeth? Sure. Maybe they landed down here, yeah? Maybe they landed down here. Is that believable? They could have landed right here, maybe. Maybe, God forbid they land over here. Because then it's like, if you can just deal with this for an hour, you're gonna have lungs of steel by the time you're done, right? But most likely they landed somewhere right around here. Otherwise you'd see two small p-values going the other way, and this is what, yeah, anyway. So here's your data. Here's your data gotten after 3 hours. Which means, let's phrase this right, after 3 hours, 2 clean hours. Can I do that, clean hours? Because we pulled you out of the room after an hour and then let you kind of air out for a couple after that. So your lungs are doing their thing. The human body is an amazing, as you know, it's an amazing thing. So now let's draw some curves. Let's draw some curves. This guy right here, this was the P less than 5% guy. He's the one that surprised us when we said, oh yeah, it looks like lung function's damaging. Is it possible that this data does belong on the normal lung function parameter curve and we just got really unlucky and got a far left outlier? Is it possible?
Yes.
Of course it is. It's just not probable. What's more probable? Not that this asterisk is on this curve, but rather that it's on some other curve that is centered lower. That's what's more likely, yes? Where exactly is this curve? We don't know. It's somewhere. It might be the same curve as this one and we're completely wrong. Hell, it might be over here and we're completely off base. But those are all possibilities. They're just highly improbable or they have low probability associated with them. It's more likely, and you got to remember this as you go through your lives too. When you witness an event, chances are the event you're seeing is not unusual. I mean, right? Think about the definition of an outlier. It's something that shouldn't happen very often. If you see something, you can bet on the fact that it's probably not an outlier. I love that one. What are the chances? Well, I just saw it, right? Pretty good. I mean, that happens all the time. Allie.
We did that this morning.
You did? Tell me.
We had 2 kids that ran the street in front of us and had to slam on our brakes, and they did it in front of 3 other cars.
Yep.
And I said, Emerson, call the school because, you know, we need to let the school know this is going on. And he's like, oh, what if it was an accident? And I was like, they just ran in 3 different cars. They probably go to school the same way every day and run those intersections every day. So I was like, just call the school. Called the school and they're like, we know who you're talking about. We'll have a conversation with the parents.
Probably just an accident. Nope! It's going to be an
I
accident.
think it's time to stop riding bikes to school. And I was like, see, it happens all the time.
Proper use of statistics, more important than any of this today, is that reaction.
I told him stats lesson this morning.
Oh, I tell you, sister, it's so huge. It's so huge to be able to realize you're probably not seeing an outlier. I told about the kid running the stop sign in my neighborhood, right? Yeah. Chances are that wasn't the only time he did it. Just like the kids, I told you about the pair of shoes I found running. Right, that's a perfect example of, oh my God, what are the chances? Well, you just found them. There's probably a really good explanation for it. It's not unusual. It's not random. It didn't fall out of the sky and land in front of you. Good for you, sister. You have to assume that when you see data, no matter how goofy, deviant it might seem, it's probably an average of a distribution. It's rare to see the goofiness. Right? It's rare to see the goofiness. It's more on average to see the average in the mode. Good for you. Good for you for calling the school too. That's fantastic. I did the same thing at Lava Ridge because the traffic at I don't know if you guys have kids who go to Lava Ridge. Egypt Road is a zoo. I went and picked up Max after school yesterday, riding our bikes home, and it's crazy. Cars pulling out. There's no parking on the side. And I told Mr. Lindsay, and I'm like, dude, I mean, every day is like this. I didn't even need to analyze it statistically. But he's like, yep, I've written this letter, and I've done this, and I've done this, and that's where you have to start throwing the numbers at the state to actually get something done. So good for you for getting something done right away. Good. Okay, so chances are, our extreme data on this curve is less extreme on some lowered curve. But how about this data right here? Now granted, it's probably the center of some curve too, but that curve looks an awful lot like the original one, right? That's what at baseline means. It doesn't mean directly back to baseline. It means close enough back to assume that they're the same curve. Fair? Good? Excellent. Let's get into this a little bit deeper. We got a little bit of time. We have to come back to this one on Thursday, which is totally fine. We'll save that in-class quiz for then too.